Do you really think Jeff Chang would die?
I don't know, do you think that could actually happen?
I don't know, we should find out.
We should. In the film, they pose a very good question. Would Jeff Chang actually die from falling 3 stories onto the roof of a car?
We decided to do our own experiment.
For our project, we'd like to observe just this.
Sam, don't jump, we're on the 3rd floor!
Most people assume that falling 3 stories would cause a lot of harm to a person.
This may be true, but there are a lot of factors to take into consideration when evaluating injuries.
When looking at injuries such as whiplash or a broken bone as opposed to a concussion, we will evaluate each of these factors and determine the outcomes by using physics principles.
The first thing that we had to do was make a few estimations about our character. We had to look at things like the distance he fell and the amount of time that it would take him to impact the vehicle he fell on. And then finally, we would have to look at what it would take for him to sustain some sort of brain damage. When making our estimations, all that we have to take into consideration are some factors about a 21-year-old Asian male. The first thing we looked at was the average height. That's around 5 foot 6 inches, which converts to 66 inches, which converts to 1.6764 meters. Then we look at the average weight. That's about 145 pounds, which will equal out to 65.77 kilograms. Then we look at the average height of a 3-story window. That's about 30 feet, and that will convert to 9.1440 meters. Then we looked at the average height of a Ford Expedition. That was the type of car that he fell onto the hood of. It's 77.5 inches, and that will convert to 1.9685 meters. Then we have to look at what factor is going to cause brain damage. What we had to find was a constant for this, and what we found was that anything greater than approximately 4.46 G will cause brain damage. And then lastly, we have to estimate a time that it's going to take him to fall. That'll be approximately 0.3 seconds. Now that we have our estimations, we have to figure out which principles are best going to aid us in making our calculations. The first thing that we decided to do was use the law of conservation of energy. The law of conservation of energy states that energy may neither be created nor destroyed. Therefore, the sum of all the energies in a system is a constant. This formula is read out: mgh equals 1/2 mv squared. We have kinetic on one side and potential on the other. What we can do first, though, is we can eliminate the mass. Since mass is a constant on both sides, we can just cross that out. So now we're going to have GH equals 1/2 V squared. Okay, for G, that's going to be gravity, so 9.8 meters per second squared. And then H is the height, which we just had to find the displacement between the top of the car and the top of the window. So that equals 7.1755 meters. Now we just have that equal to 1/2 V squared. So we're going to solve for velocity. When you multiply this out and then divide it by 1/2, you end up with 140.6398. And then since this is squared, you're going to have to take the square root on both sides. So then you get V is equal to 11.859 meters per second. Now that we use the law of conservation of energy, we're going to use a new equation to continue. We decided that Newton's second law would be the best one. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it. Its equation is F times delta T equals M delta V. We can break down the F to be mass times acceleration, and then we have delta T equals M delta V. And now our masses are going to cancel, so we actually didn't even need to find the mass of the character. But now we have acceleration times delta t equals delta v. The acceleration is going to be equal to the constant we found earlier, the 4.46 times g, and g is just going to be 9.8 because it's gravity, and then that is going to ultimately equal 43.708 meters per second squared. Okay, now we just have to find the change in time, and then that's equal to the change in velocity, which we just found, and that's 11.859 meters per second. Now, simple algebra, just divide by 43.708 on each side, and then we solve for delta t, which ends up equaling 0.2713. And now what this means, since this is now the new constant that we have, and it basically is just going to tell us that anything greater than this should mean that a person is okay, and anything less, the person will receive injury. Since we estimated the time to be 0.3 seconds, our character will be okay. Jeff will be okay because his time of impact was longer than our calculated time. He will not obtain a concussion, and because he was asleep, he will not get a broken bone or receive whiplash. Sam, on the other hand, tensed up and is now paying the